All right, well, here we are again. Welcome to my latest Weather and Climate Office Hours. This one will be another split between talking about the short-term weather in California, which once again looks active, at least for the next few days, and then thinking a little bit bigger picture across western North America for the upcoming summer and autumn. And also globally, since there continue to be a lot of conversations about warming and warmth and all sorts of things that have unfolded in recent weeks and months and over the past few years. So, as always, covering a lot of ground, starting with the local weather and expanding outward from there. So welcome, everyone. Thanks for joining. California has seen quite an active winter season. Once again, it has been pretty backloaded, meaning that there's been more winter storm activity in the latter half of the peak wet season months. For example, October, November, December were not particularly active months in many areas, with some places seeing well above average temperatures and below average precipitation during that interval, especially in the Sierra Nevada. But January through March was quite a different story in many regions, where it was generally wet just about everywhere, and also cooler. So there was major accumulation of snow in the mountain passes. Snowpack, as of April 1st, ended up right around or just above the average mark, unusually average, as some folks have called it. So, in other words, California, the coastal areas have been quite wet this winter, wetter than average almost everywhere. And some parts of Southern California may end up around between 150 and 200% of average for the water year to date. So, in some places, half or 50% more, or even double the average amount of precipitation in that part of the state. Notably, those are not record-breaking numbers because in Southern California, there is a lot of year-to-year variability, so you can double the average and still not see record-breaking precipitation, at least at seasonal scale, because we have some seasons where we've seen even greater than double the average. But nonetheless, it is the second consecutive wet winter in most of California, and that has been rare in recent decades. Last winter was exceptionally wet in many places. This year, still above average in most places, except near average in some parts of the Sierra Nevada. There were a lot of coast-hugging storms this season, so it has been comparatively wetter along the coast than in inland areas. Nonetheless, it's not like inland areas have been extremely dry this year. They just haven't been much wetter than average, as has been the case for much of Central and Southern California coast. And snowpack, notably, is looking quite good. So even in the mountains, where precipitation was near to slightly below average, snowpack managed to, thanks to the really big snowstorms in February and March, reach average levels. So not expecting a major spring snowmelt flood risk this year, by the way, in California. You never know if there's a really extreme late season warm atmospheric river or a huge May heat wave. But right now, not looking like a significant year for snowmelt flood risk on average. Your mileage may vary in a particular watershed, but overall not looking like the kind of risk we had last year broadly in the San Joaquin and in the east side Sierra basins. There just isn't as much water up there potentially available to melt this season. So that's good news, and it's good news because in general, California, I think, won't have acute short-term water shortages or concerns this in 2024. Does not mean that we won't see a transition towards drier and hotter conditions later this year. I'll talk about that a little bit later. And the fire season, 2024, might look quite different than 2023 in the sense that it could be a lot more active, both in California and broadly across the West. But still, in terms of water supply, reservoir levels looking good, snowpack looking good, so we're not going to see the D word, drought, show up in the lexicon this year from a human water, consumptive water use perspective. Will be interesting to see how far down that path we end up in ecosystems and in terms of soil dryness as we head towards fall and next winter, but I'll talk about that a little bit more in a moment. Short term, more water is coming. In fact, there is some water falling right now. over portions of Northern California, particularly the northern third, where there's even been a line of thunderstorms that has popped up over the northern parts of the northeastern Sacramento Valley, foothills, and western slope of the Sierra. There have been a lot of thunderstorms this season, as we've talked about before. This is no exception. This is going to be yet another system that will bring yet more thunderstorm chances to a pretty big chunk of California. In fact, the system coming in over the weekend, beginning later today through Saturday and Sunday, actually looks pretty robust for mid-April, in the sense that it will bring widespread precipitation. Probably nothing earth-shattering, but it could be significant. Some spots will accumulate more than an inch of rain, which is a notable rain event in April. Some hefty April showers, even though they may be showers, they won't necessarily be light rain. Could see some real downpours out there, along with those thunderstorms. And I'll take a closer look at that in a moment. But another rain event at lower elevations and another snow event in the mountains. The snow levels are not going to be as low with this system as the really cold last system California saw, so probably won't see disruptive low snow in the same way that we did last time. Then again, snow levels will be on the lower side for April. Nothing record-breaking and not as low as the last system, but still, it is April, the sun angle is increasing, so when we have these cooler systems this time of year, on the one hand, it tends to lead to thunderstorms due to the instability of the atmospheric profile, those steep lapse rates, the increasing rate at which temperature decreases with height because the upper levels are just as cold as they were in winter, but the surface is a whole lot warmer. And also leading to some lower snow levels where there are some years where certain parts of the foothills and higher coastal mountains in California actually see their lowest snow levels of the whole season in spring when these systems come ashore. And I think there were some places that probably did experience that with the last system a week or so ago, which brought localized accumulating snowfall down to 1,500 feet or even a little bit lower in some parts of Northern California. I think those were essentially the lowest snowfall accumulations of the season in those places. So it doesn't mean that the air overall is record cold or that it's gotten really cold in April. It just means that storm had unusually cold air aloft and the precipitation was able to drag it down pretty close to the surface. But the weather otherwise this April has been quite springy in the sense that it's been very changeable, more so than some years in California. It's been genuinely warm on some days, places getting into the 70s and 80s in recent days, but immediately to fall back down 20 or 30 degrees with significant precipitation thereafter. Some California springs are like this. I know folks who lived in California primarily in the last decade through all the big drought years think this is super unusual, but in fact this is something that tends to happen a few years per decade when we're not experiencing historic drought. It doesn't happen every year. Some springs are a lot wetter than others. This is certainly not a record wet spring so far, but also far from a record dry one. So really, again, relatively beneficial precipitation for most interests. I know sometimes spring rain can be a challenge for certain agricultural growers in the Central Valley, but from a fire and water perspective, it is good to be getting this precipitation still. Top up the snowpack and keep things wetter longer into spring. This system will again do just that, along with bringing some additional thunderstorms. And so I'll share my screen for a few minutes. This won't be a long screen share, but I will take you on a brief satellite and radar tour because I think it's interesting right now. Let's see where this pops up. Yes. All right, you're going to see a screen, not the screen I want you to see initially, but it's going to toggle over to the one I do want you to see, which is this one. You should be seeing low pressure systems swirling off the coast of California, satellite imagery, and that is depicting this low pressure system that's going to move in this weekend. Really later today, I guess it's already Friday, so this is a system that's going to already starting to affect parts of Northern California with some showers and bands of isolated thunderstorms this afternoon, especially over the North Valley and the Sierra Nevada foothills. That will become much more widespread into tomorrow. And whoops, it looks like I'm not sharing, that's why. There we go. Okay, now you're seeing what I intended you to see while I was just rambling on there. that satellite image with this nice, well-defined low-pressure system off the coast of California. It's not as spectacular as the last one I mentioned, but it is, again, pretty respectable for spring. A few interesting things going on, and I'm going to show you with the cursor. You can see there's a pretty robust marine layer along the entire coast of central and southern California. So these are not storm clouds associated with the low pressure system yet. This is essentially just marine stratocumulus. You can see this classic marine stratocumulus bank over there, making it pretty far inland and to some of these inland valleys, about as far north as the San Mateo County coast. In fact, there's a bit of a southerly surge happening. You can see this this marine stratocumulus sort of surging up towards San Francisco. There's a couple of little micro-scale swirls, sub-mesoscale swirls in the marine stratocumulus offshore. You can see the snow over the mountains. You can see some cumulus clouds popping up over that Sierra Nevada snowbank. But as you go north of about the Highway 80 corridor here, you see that there are both high clouds streaming due north ahead of this low pressure system, and also a couple of lines of showers and thunderstorms popping up in the northern third of California. Offshore, again, not much of a frontal band, but plenty of popcorn-style showers and isolated thunderstorms offshore. It's not this initial frontal band that's going to bring much rainfall, but it is in fact all of this instability and these heavier showers and isolated thunderstorms offshore that will bring the active weather later today into tomorrow. And I'll take a quick share of the radar right now. I'm going to change over to you'll see my radar scope app once again on your screen. I'm not seeing it full screen currently, so I need to increase the size of the screen here. There we go. Now that's what you're seeing in front of you. And what you can see is that there is, this is the radar in Sacramento, which is not capturing everything. You can see these lines of almost due north-south, south to north bands of clouds that are mostly producing virga, which is to say precipitation that's not reaching the ground. But over here, these are the showers and thunderstorms that have been reaching the ground. Sacramento radar is not seeing it so well. If I go closer up to Beale Air Force Base radar, they're a little bit too close to the radar, meaning I may have to go to a higher tilt in the atmosphere to see them. And let's see what happens if I do that. Yeah, you can see them a little bit better here. So you can see that they've weakened a bit, but there were some thunderstorms up between, in sort of this triangle between Chico, Chester, and Bernie. Would expect to see potential for more later today, generally sort of in this region. So I wouldn't be too surprised to see some isolated thunderstorms popping up later. And that's probably about it for the radar tour, because there's not much else going on elsewhere at the moment in terms of the radar. So now you're going to see me switch over once again. You're going to see satellite again briefly, but what I actually want to show you here is the weather model representation of the system offshore. So you'll see it. This is sort of where we are now-ish. This is right around sunset this evening, so you see this area of isolated showers and thunderstorms in the valley and the foothills expands. This evening moves inland, mostly dry, still Bay Area and Sacramento region. But as we go into the overnight hours, by early morning hours, expect there to be a pretty significant band of precipitation, showers again, and isolated thunderstorms all along the coast, from especially Mendocino County down through Monterey County, but also some lighter precipitation developing in Southern California. And this whole system slowly swings through, bringing some widespread moderate precipitation with some locally heavier downpours in northern and central California, and some widespread light precipitation in far southern California, with a secondary low moving through. This moves through on Sunday in Southern California, might actually bring the heaviest precipitation of the whole event to parts of Southern California. This will be yet another system characterized by a decent amount of atmospheric instability, which I can show you here. Not too tremendously much. You can see what's there today is actually maybe the most decent instability of the whole event. That's why we're seeing some foothill thunderstorms this afternoon. But there is also a little bit Saturday afternoon. Really not too much Saturday afternoon, but maybe still enough for some isolated storms. And then once again on Sunday, just enough for some isolated storms over Southern California as well. This does not look like a system that's likely to produce significant severe thunderstorm activity in California, although this time of year, 1 or 2 cells is always possible. This is sort of the kind of precipitation we're looking at, which again is pretty respectable for mid-April. About a half an inch to an inch in most of northern and central California, locally up to 2 inches, parts of the central coast, and up in the Shasta Mountains. So again, no major flood concerns, but a pretty decent soaking across a pretty wide swath of California. The only parts of California that are likely to miss out are the lee side of the Sierra and the coastal, far southern coastal California. So Orange and San Diego counties probably won't see too much out of this. LA County may or may not, depending on whether there's any thunderstorms on the backside. But everything north of LA County should see some decent rain. If we push this forward in terms of potential accumulations over the next couple of weeks, we see this is what's accumulating this week. And really, there's a little bit more that accumulates, but things really dry out. So the second half of April looks drier, considerably drier than the first half. And we may see some more above average temperatures as we head towards April 20th or 23rd or so. So again, spring-like changeable weather, nothing too dramatic to report there. All right, so I think that pretty much covers the weekend system because doesn't seem to be all that dramatic. So I'm gonna share something else now. Well, actually, let me first. You'll see me again. Hello. I do want to talk a little bit about the relatively wet year, especially the fact that it's the second wet year in a row, means in the broader context of things for California, and also what the rest of the western U.S. and really western North America is looking like moving forward the next few months, because we know that from last year, much of the continental eastern half of North America, including the eastern U.S., suffered through a really terrible summer of smoke, not because there were huge fires in the eastern United States, but because there was so much fire in Canada, all the way from British Columbia eastward to the Maritimes, that there was just this continuous plume of smoke draped across much of the continent, despite the fact that the west coast of North America was actually doing pretty well. There was not a big fire season in coastal California or Oregon, for example, last year. So we didn't have that smoke. In fact, in general, across much of the western U.S., it was a fairly quiet, with some exceptions, fairly quiet fire season last year, as predicted, based on the antecedent meteorological conditions. So what do we have moving forward? Well, it probably helps to first contextualize this with the fact that California's wet winter does not extend to much of the northern interior of the Pacific Northwest, nor to the interior of Western Canada. In fact, large portions of the interior of British Columbia and Alberta, as well as northeastern Washington and northern Idaho and Montana, are experiencing significant drought conditions that get worse the farther north you go into Canada. And so there is a vast swath of Canadian boreal forest that is once again experiencing severe, extreme, or even historic drought, much as was the case this time last year. And this is really the opposite situation from California, where we've had now 2 wet years where the benefits to a certain extent compound over those years. The harms from the extremely severe drought up in western Canada and some of the northern interior parts of the western U.S. compound over years as well. So there's every reason to believe that based on the antecedent conditions, the low snowpack conditions, the extreme drought conditions up in western Canada and certain parts of the northern interior of the western U.S., that these regions are likely to see severe fire seasons in 2024. So be prepared for that. That really is anywhere from the interior of British Columbia eastward into central Canada. So the vast swath of potentially highly flammable and potentially highly smoke-producing forested regions there. And that will somewhat depend on how the weather and climate evolves over the next few months, but I'll get into that in a moment. As we go farther south and closer to home, California is not going to see an early start to fire season this year. It's nice and damp just about everywhere where we can see fires in California, and we're likely to get another soaking rain across most of that territory just this weekend. And it may or may not be the last one of the season. There could still be some more April or May showers to come. That wouldn't be too surprising. We do have the benefit and the legacy of 2 consecutive wet years. So the forests right now are going to be experiencing pretty respectable soil moisture through at least the middle of summer. So I would expect a near to below average fire season in the first half in most places in the forests in California and in many adjacent western states where there's a decent snowpack this year. However, as we go towards early to midsummer in some of the drier and hotter parts of California, so thinking about the places where we don't often talk about wildfire in California, like the southeastern desert regions, they've made the news more often because we've seen damaging wildfires in places like Joshua Tree National Park and in certain parts of the Mojave Desert, including the National Preserve there. I would expect to see another relatively robust start to the fire season in the deserts earlier versus later, so in May or June before the summer monsoon, because there is so much additional growth from relatively wet conditions there the past couple of seasons. So in deserts is where we often see worse fire seasons when it has been wet, because there is an additional growth of vegetation. It fills in the gaps. Sometimes in a particularly harsh desert, you might actually have discontinuous vegetation. So if lightning strikes a Joshua tree or something, it might burn that Joshua tree and some adjacent patches of brush, but often there are just so many natural fire breaks in desert ecosystems because of non-spatially contiguous vegetation. Those fires tend to be quite small and burn themselves out. However, for 2 reasons. One, because there is an increasing level of invasive grass in a lot of the western U.S. deserts, which fills in the gaps in some unwanted ways. And also in years like this one, where it's been relatively wet, we tend to see more growth of that grass that fills in the gaps and gives you a more continuous fuel bed and more fuel to work with in general. So these are the kinds of years where we do tend to see earlier onset of the fire season in non-traditional parts of the West, in places that are often too dry and too vegetation sparse to burn easily, do tend to burn more readily in years like this one that are wetter. And then elsewhere in California, I think that the second half of fire season this year could look very different than the first half. So again, a near to below average start would not surprise me at all, especially in upper elevations where there really won't be any activity to speak of, at least through June and maybe through July at high elevations. But after that, I'm not so confident this year that things won't pick up pretty dramatically thereafter for a few reasons. One, this year hasn't been as extremely wet as last year, particularly at higher elevation regions. And so while snowpack is quite respectable, and while vegetation moisture is near to above average currently, we do know that in a warming climate, the thirstier atmosphere is driving increased rates of evaporation, making soil drying happen faster than it used to historically, and allowing vegetation to reach peak seasonal dryness earlier than used to be the case. So this year we have the opposite of a running start. We sort of have a starting penalty in terms of fire season, meaning that things will stay wetter longer than they would have in a more typical year in terms of moisture. But we know in a warming climate, our summers are getting hotter, our autumns are getting hotter, and there's evidence that on average, the rainy season is starting later in autumn than it used to, so that we see more overlap with the dry vegetation in autumn and offshore wind conditions in autumn, even though there's no evidence at this point, no strong evidence that climate change has affected the offshore winds themselves in any discernible way at this point. So what we've got is a season that may get off to a slow start, but may rapidly pick up. And then I would actually, if I had to guess, I would expect that this year would be considerably more active fire season than was 2023 in California. But I expect there to be a bunch of misleading headlines around June or July saying that California has seen a very slow start to fire season. This is great news because we're going to see a mild fire season. That's kind of what we've seen in previous years like this one. In fact, there were some headlines like that in 2017. And then remember what happened in autumn of 2017. We saw those headlines because we had a record wet winter in Northern California. So I think a lot of folks conflated record wet winters with record mild fire conditions. But that is not, in fact, so simple, especially in a warming climate, because we then experienced the hottest summer on record and one of the warmest autumns on record in 2017 that followed the wettest year on record in parts of Northern California, meaning that we had all of the vegetation build up from all of that excess moisture, so lots of grass and brush growth, which then proceeded to dry out to record dry levels by early autumn when the winds came. It's impossible to make a prediction about whether this year will look kind of like 2017, but I think there's a chance that this year's progression in terms of fire season in California will look more like 2017 than 2023. That does not mean that we're necessarily going to see devastating fires this year. That's, again, impossible to predict and somewhat based on luck. But from a seasonal predictive perspective, it does look more likely that the second half of summer could be a whole lot warmer than the first, and that the coming autumn may be drier than average. Right now, there are some emerging signals. It's very early, but if there's any tilt in the odds right now at all, it's definitely towards a drier than average autumn. So if we do see that delayed onset of the rainy season and the early arrival of the winds, we will probably see a lot of vegetation drying that gets us to pretty high fire risk by that point. So that's sort of what I'm thinking, is that the slow start, which is quite likely, may give way to something that is not slow by mid to late season, particularly by the end of the season. And why am I talking about mid to late season? Normally, we wouldn't be able to say much of anything at this point. It's still April. I'm talking about June, July, August, and even September into October. So how the heck am I looking that far ahead? And this is where I wanted to show a different screen. So you're going to see the wrong one initially. But then I'm going to transfer over to something a little bit different. I don't think I've shown this on screen. And actually, what I need to do is shift there we go. So the window, you actually see what I want you to see here. That is better, I believe. Let me just double check that that's actually showing up as intended. Yes, it is. Okay, so this is the seasonal outlook. This is a different seasonal predictive system than the one I often show. I often show the American model or the North American blend of models. This instead is the European blend of models for seasonal prediction. And the reason I'm showing it at this point is that it is essentially fair to say that it is at least slightly better than the American ensemble. Sorry. And also because right now the graphical interface is a little bit easier to interpret at this scale. So what I'm showing now on the screen is this is, by the way, you can access this. This is all public via the Copernicus data portal through the EU extension above. This is a blend of multiple models from different countries. So this is the ECMWF model, which is a sort of a collaborative model across a consortium of European countries, as well as the Met Office model. That's the UK Met Office, Media France, which is of course the French Meteorological Service, and then several others. DWD, that's Germany. This actually does include also the American model, so that's the NSET model. As part of the blend, the JMA is the Japanese Meteorological Agency. So essentially, this is a blend of all of the different seasonal predictions from most of the models produced by most of the major modeling centers on Earth. So a pretty good sense of this is the C3S multi-system seasonal forecast. Generally speaking, when it comes to predicting the future, your best bet is to use the largest ensemble you can get your hands on, and this is the largest ensemble I can get my hands on. So these are based on predictions from earlier this month, so these are up to date from April. Here's the next few months. This is again the average predicted temperature anomaly departure from average across the Earth. And you can see the spatial patterns of warming. There's, of course, vastly more orange and red than there is blue. In fact, there's very little blue anywhere, meaning that, of course, the Earth is warmer than it used to be. But as always, some places are relatively warmer than others. This, what I'm showing right now, is May through June, so this is starting next month for the 3 months, sort of late spring, early summer type thing. Again, looking at the United States, what we see is, of course, virtually everywhere is likely to be warmer than average. California, perhaps the least above average of all places in North America, which it is sometimes the case in the spring in years like this. But notice that I was talking about the northern tier of the US and Canada being one of the warmer places relative to average in the whole world this spring. That's not going to be good for Canadian and northwestern US fire risk later this summer. As we step through, this is June, July, and August. California, again, a little bit in this patch of maybe not quite so much above average as other places. But look at the interior west in Canada, again, just baking. This is peak summer, June through August, and it looks like it is going to be a hot one across the central US and pretty much all of Canada. That's, not, again, really not what we want to see. The other thing we're seeing at this point as we head forward, now this is July through September, so we're getting into autumn, is later in the summer going into autumn, California warms up. California is now no longer in the coolest spot, especially across inland areas, starts to warm up in the ensemble average, and the interior west and central and western Canada continue to bake. This is suggestive right now that the likelihood of really warm conditions later in the summer and into fall are actually higher than the earlier half of summer. And again, that's not just saying that, well, of course, midsummer is warmer than June. This is saying relative to average for each time of year, the late summer and autumn are likely to be the warmest anomalies relative to what it would normally be at that time of year. And so as we get into July through September, we see that there are really warm values across a lot of different continental regions, from southern Europe, northern Africa, much of Central Asia, South America, really just Central South America, really just kind of blowing out of the water there. And again, the only cooler than average place being the eastern tropical Pacific Ocean, probably part of the reason why California isn't quite as warm as some other regions. This is the La Nina signature developing that we've been talking about. So by late summer, early fall, pretty robust La Nina signature looks like it's coming into play. And temperature seasonal outlooks for seasonal temperatures are usually better than precipitation, but if we do look at the equivalent maps for precipitation, this is a little bit misleading, and so I'm going to zoom in because the scale doesn't quite work at global scale. So zooming into North America, we see that there's not much of a May, June, July type signal in the western U.S. Maybe some dry conditions resulting in higher than average fire risk sort of in New Mexico and eastern Arizona mountains before the monsoon arrives, so that's something to note. Western Canada, there's a slight dry signal in that region of drought, so not helpful. Notably strong dry signals in Hawaii. But as we go forward into summer, that dry signal across the southwestern U.S. actually expands quite a bit. And this is essentially telling us that right now there's a pretty strong consensus among the models that this could be a weak monsoon year in the desert southwest. So we don't have great predictability of monsoonal precipitation, but also in the core monsoon region in northern Mexico in the Sonoran Desert, there's a 60 to 70% chance across the ensemble right now of conditions falling below the driest third. So that's a pretty strong signal. And in fact, if I go back to ensemble mean, this may be a little bit harder to interpret. But so I'm actually going to go back to this. I'm actually going to go back to the tercile summary, since in this case it's a little bit easier to interpret. As we go through July through September, though, this becomes even more pronounced. And it also starts to extend into Southern California, and really the entire West is likely, according to the current ensemble, to end up drier than average. Of course, the signal is weaker. I would kind of ignore this lightest yellow color. It's not a very strong signal, but the two darker colors here, this is a pretty strong signal for a weak monsoon year. And again, we don't have great seasonal prediction of monsoonal patterns, but right now, this is about as strong a signal as you ever see during the monsoon, and it is pointing towards a dry one. This is another reason why I think the relatively mild start to fire season in the western U.S. might not hold. There is reason to believe that we might see a pretty hot and dry summer across a good portion of the interior west. That would extend into interior of California too. So coastal California strip, where most everybody lives in California, the vast majority of its population, your mileage may vary because the monsoonal precipitation there is near zero. This doesn't really apply. But across inland areas and across much of the interior west, this is a bit of a conspicuous signal right now. And let me see if we can extend this a little bit. If I go looking at the 1 month maps, let's see how far out this goes. Again, zooming in to North America, and this is just for the month of September. But one question will be if next autumn is dry across California, so not just September, but perhaps October as well, and maybe parts of into November, then the ability of fire season to achieve a lot of activity late in the season, so not even just back weighted, but like the last month or two of fire season, could be rough across a lot of the west, and that might be true in parts of the interior of California as well. In particular, if I go back, I'm going to try and pull up one more thing, the 1 month, the temperatures and I'm going to zoom in again on the northern, well, that's the northern hemisphere. That's not quite what I was looking for. North America is what I want. There it is. This is the tercile summary, but I'm going to go back to ensemble mean anomaly. Again, May does not look particularly warm across most of California, but temperatures, especially across the interior of California, warm. This is June, July, and then August. That warm signal shifts closer to the coast, and in September extends to the coast. So again, August and September could, right now in these models, are showing up as quite hot across the interior west and also dry. And I would expect that the autumn signal will continue to be warm and dry into October, November. Again, there's no guarantees. We could get another Hillary-like tropical storm that would defuse the whole situation, although that's not likely. But that's currently where I'm leaning, and I think we will see some misleading indications as to how fire season is going to play out based on the first couple of months. So May, June, July might not be all that dramatic, except for some of the exceptions that I mentioned. Things could really turn around after that. All of this, again, in the context, you'll see my face again, all of this in the context of a season that is not looking bad from a water supply perspective. In fact, you really couldn't ask for more in our climate change era to have a couple of back-to-back wet years without any widespread catastrophic flooding, 2 above average, or at least near 2 above average snow years. The water supply will be in fairly good shape. Now, next winter could be a very different story in terms of how wet it is, and we could be having a different conversation about the D word, the drought word, this time next year. But even then, we won't be talking about extreme drought yet, simply because we will have some reservoir, groundwater, and even ecosystem soil moisture water carryover from this year. So this year and last year are definitely going to help us this year and could help us into next year as well. But if next year is dry, we'll lose a lot of that carryover, and then if the following year, is dry, then that would be another drought conversation we'll have. So that's all speculative. That's all out there. In the future, the spring looks pretty great. There'll be a nice green up. There should be good flowers. I hear there's already great flowers in the deserts in many regions. Those will pop up elsewhere where they haven't already. I'm sure sooner rather than later. But that's what I'm thinking about in the big picture right now. So I'm going to go and take a look at some of the questions right now. And if there aren't too many, there's actually a couple of things that I would like to share that I think will be of interest if we have the time up to the hour. So I'm taking a look at questions right now. Take a sip of water. Yeah, a lot of folks talk about there's some wildfire wildflower talk, excuse me, in the comments. The desert ecologists will probably roll their eyes at the term super bloom. Some years, of course, have more widespread and vibrant displays of flowers than others. But it's not always the wettest years that result in the best growth and displays, because of course you need that sunlight, and you need those non-damaging rainstorms to help out with that growth. So it's not just a question of how much water is available. So in a lot of places this year is pretty good because we have had that mix of water and sun alternating, which is it's ideal for plant growth. This is one reason why I think that we may have to watch out for fire season later in the back half of this year and then moving forward. But in the meantime, it means that it's a really good growing year for a lot of plants in California that could really use a leg up after kind of a rough decade. So I'm sure there's flowers all around California right now, and if they aren't in your area, they've either potentially already peaked in some spots or yet to peak at higher elevations in others. Mary mentions that Mount Diablo is a sea of poppies right now. Sandy mentions similar conversation about the super bloom. Point raised wildflowers might be pretty good. Yes. Yes, it's not great news that the Southwest might see a weak monsoon this year. Granted, the predictability is not high, so this is not a very strong prediction, but it is right now where the multi-model global consensus is leaning towards a drier than average monsoon. And it would be a problem because ended up having a fairly weak monsoon last year. And so, the Colorado River benefits both from winter snowfall in the northern Colorado Basin, or the upper basin, really, as it's officially called. But the monsoon can be relatively important for the lower basin, and so we have decent snowpack in the upper basin this year, which is good, which will somewhat counterbalance, at least from a Colorado River flow perspective, the consequences of a bad monsoon year. But that does not help counterbalance the wildfire risk associated with a really long, hot, and especially long, hot summer and a poor monsoon, which is looking plausible this year. So mixed news on that front. As I mentioned, I do think this is going to be a significantly more active wildfire year across much of the West than was last year. Lauren mentions that coastal Santa Barbara County has grass growing tall in places I haven't seen grass at all in 40 years. So that's an indicator that these wet conditions the past year or two are starting to fill in the gaps, which is great in some ways from an ecosystem perspective, but it does mean that once the conditions do dry out, that there is more fuel potentially ready to burn and more continuous fuel in some places, as Lauren mentions, where the vegetation might have been somewhat discontinuous. And that would be true sort of in the sparser grassland regions and also in the deserts. Question about whether the Pacific Northwest might see drought or fire relief this upcoming autumn and winter due to La Nina. It really depends how strong it is, and the relief might not come till winter, which might not help much with drought and fire risk this summer and autumn. So there's no guarantee of an early onset to rainfall, and we'll just have to see what happens up there. That's still a little bit far out. But one thing, since we do have a few minutes, that I did actually want to share, and I'm actually going back over to Twitter. I have a very hard time calling it X still. I'm probably not the only one. But I'm going to share a non-Twitter link. This is a perspective piece by someone who some folks may be familiar with, Stefan Rahmstorf. And he's a scientist in Germany at the Potsdam Earth System Research Institute. I'm not 100% sure I got the full name correct, but the reason I'm bringing this up and you're going to see this link show up in the chat, I believe, momentarily. Let me just make sure I have the right link, and then you're going to see it show up now. Is that this is an open access perspective piece in the peer-reviewed journal Oceanography, but it is focused on the Atlantic Meridional Overturning Circulation, or the AMOC, which has been in the news recently because there have been some pretty bold and alarming claims about what might or might not be happening with this global ocean current system due to global warming and the subsequent changes in things like the buoyancy of the surface layer of water in the North Atlantic, which sounds in many ways very esoteric, but has enormous implications for global climate. Because, of course, if this system were to become significantly disrupted or collapse, all of the somewhat exaggerated things that people sometimes say about climate chaos and the whole system just falling apart and being unrecognizable might actually come true in terms of complete rearrangement of continental scale weather patterns and circulation patterns. If that ocean current system were to collapse, there's indication it could do so extremely fast on geological timescales over the course of a decade or two. So, in other words, well within an individual human lifespan. We don't really know how close we are to that collapse, and there is a wide range of opinion among scientists, ranging essentially from we don't even think this is a system that is particularly constructed in a way essentially that it can easily collapse, to others, including Stefan Rahmstorf, who wrote this perspective, who argue, I think somewhat convincingly, that we really don't know how close we are, and that the system almost certainly does have the ability to collapse rapidly, either as a result of sudden injections of fresh water near the surface, which of course is less dense than cold salty water, meaning that you sort of shut off the overturning part of it because the cold salty water no longer sinks because now it's cool fresh water instead of cold salty water. So you can shut off the system that way by disrupting the buoyancy through salinity. Say if Greenland sends a whole lot of meltwater to the North Atlantic quite fast. We know it's doing so quickly now, but if that process were to significantly accelerate, which there's some chance that there would, or essentially just through the regional shutdown of different parts of this current system through essentially random variation. So if we get unlucky with a particular phase of ocean climate variability in the next few decades, plus the deliberate unluckiness, if you will, from the climate change kick to the system, could that be enough to tip the AMOC into a completely new state? And the answer is we don't know. Stefan Rahmstorf essentially has personally and professionally estimated that there might be a 5 to 15% chance that this happens this century, which sounds like a pretty low number until you realize what the consequences of it might be. And just for perspective, this is a physical oceanographer, somebody who understands the nonlinear internal dynamics of the system quite well, who has devoted his career specifically to studying in large part the AMOC itself, and someone who was initially somewhat skeptical of the potential it could collapse within relevant human timescale, but is much less skeptical as he's progressed in his career and studied this more and more. This is just one scientist, but it is not a complete outlier view. There are other scientists who have similar views, and I thought that this perspective piece offers a pretty balanced perspective, as well as a very readable perspective for a fairly general audience. I think most folks who can sit through an hour of me having these kinds of conversations can probably read this article and understand most of it, and at least understand the key points of what is this system, how does it function, why is it so important for global climate, what would the risks be if it did either completely collapse or if certain branches of it in certain oceanic subbasins were to collapse. Even the latter would have enormous continental scale implications. And what is the state of the science right now as to what could happen in a warming climate? How close are we to collapse? Is this a system that can collapse from the kind of changes that are plausible to unfold in the coming decades? The fact that the answer isn't no, this can't collapse, or no, there's no way we're going to get there, I think should give everybody pause, because this is one of those big bad things that I refer to somewhat euphemistically and vaguely on purpose, because they are kind of big and nebulous and not always very well understood, and there are a lot of them, and they're not unrelated to each other. But right now, this is the one that's getting a lot of attention because there are some papers suggesting that perhaps there are some early warning signs that we are getting close to this critical instability. And there's been pushback to some of those papers as well, to be fair, but I think the real answer is that nobody can convincingly prove that this definitely isn't a problem. Even the most the most skeptical scientists at best have argued that it's quite unlikely that this will happen, but not that it's impossible or that it can't happen this century. Whereas on the other side of the spectrum, the argument is essentially that this is a plausible and growing threat, even if it is more likely than not to happen. That's not particularly reassuring for an event that would have consequences of this magnitude, including the dramatic cooling of northern and western Europe by multiple degrees over just a decade or so. That would be a genuinely catastrophic and sudden change of climate. Think about all the climate change impacts we're seeing globally when global mean temperatures have increased by less than 1.5 degrees centigrade on a multi-year average. And think about and that's over about a century and a half. The AMOC could result in temperature changes in certain continents on the order of 4 or 5 degrees centigrade over just a decade or so. So double or triple the rate of the climate change that we've been seeing, at least at subcontinental scales, but in the opposite direction in Europe, but amplifying climate change in places like the southern hemisphere. So you'd see double the rate of warming that we've seen in places like Australia and parts of South America. So in other words, we don't fully understand exactly what the world would look like without an AMOC, but we have a pretty good sense, and it looks quite different than the world that we have right now. And the big challenge with climate change, of course, it isn't even really the end state of the system so much. That is the problem per se. It's the fact that we humans in our society and our civilizations, as well as ecosystems that we live with all around the world, are adapted to the climate that we've experienced recently. And what recently means something different, because the timescale of modern civilization is much shorter than most evolutionary timescales over thousands and even millions of years. Of course, civilizations rise and fall over centuries to millennia. Millions of years is still just a vast number compared to the age over which we've essentially developed all of global culture and all of our cities and all of our technologies. And so the problem is encapsulated really in the statement, rapid change is bad. It's bad for ecosystems, it's bad for us, particularly bad for the kinds of civilizations and societies that we've built, which are fairly predicated on relatively stable climate conditions. So deviations from that expectation are bad in any direction, especially if the direction is different on some continents than others, as could be the case with a major disruption to the AMOC. So this piece that I've shared, it does not offer direct new evidence. It's not a scientific research paper unto itself, but it's a very nice and elegant summary of the work that has gone into this so far. I think it's a reasonable overview of our scientific understanding of how the system works, what its potential vulnerabilities are, and what the prospects are for dramatic change in a warming climate. Just to be clear, even Stefan does not claim that the collapse of the system is obviously imminent, but the important caveat is that it's not clear that it would be obviously imminent even if it were. And I think that's where the precautionary principle comes in. If we wouldn't see this coming, really, before it happened, and we know there's at least a modest chance, at least a 5 to 10% chance it could happen this century, and we know that the consequences would be stratospherically high if it did, uh, then it just doesn't seem like something that we can ignore. And the challenge is there's not a whole lot we can do to adapt to it because the changes would essentially bring such chaos. The only thing that we can really say at this point is the less global warming we end up experiencing, the less likely it is that this current system tips into a new state. Whatever the likelihood is today, it will be higher once we hit 1.5 degrees in the long term. It'll be higher once we hit 2. It'll be vastly higher if we end up getting to 3 degrees centigrade. So this is a classic example where every 1/10 of a degree centigrade of warming is a meaningful reduction. I should say it this way, every 1/10 of a degree centigrade that we don't warm is a significant increase in that risk increment that we've avoided, but every additional 1/10 of a degree of warming that we actually experience in the real world is another notch upward in the potential likelihood of experiencing one of these big bad things, like a collapse of the Atlantic meridional overturning circulation, or some of the other big ones like a sudden collapse of the West Antarctic ice sheet, or a dieback of the Amazon rainforest. All of these would have different implications. The one that would cause the most climate chaos would probably be a collapse of the Atlantic, or the subarctic overturning circulation as well. There is another overturning circulation in the world that appears at least somewhat susceptible to sudden changes. The collapse of the West Antarctic ice sheets would be primarily a concern for rapid sea level rise, where we would see vastly faster than expected increases in sea level, which would of course have just enormous implication for all coastal areas on Earth. And the Amazon itself, that kind of tipping point, it is a little more regionally constrained. It would be potentially devastating for the Amazon basin itself and would have some global climate consequences, partly because you'd see a big pulse of carbon into the atmosphere and you'd see further warming globally from that. But the AMOC, in a lot of ways, is the biggie of the bunch. And it could trigger, if it happened, it could trigger some of these other tipping points. So the likelihood is autocorrelated, so they're not independent events fully. Once you trigger one of these, it becomes somewhat more likely that you'd hit other ones. So this is an interesting session in that I've talked about everything from the weather over the next few hours to the next few days to the next few months across the continental scale to the climate, including some thoughts about climate tipping points all the way out decades in the future that would affect everybody on Earth. So time and space covered a lot of it in today's conversation. And then since we're at the hour, I'm going to look at the comments, see if there's any questions at this point. But otherwise, this will be more of a unvarnished monologue and thoughts from Daniel Swain kind of day, and I'll call it an afternoon. Well, let's see. Not too many comments today, not too many questions. So I think I might leave it at that. Thank everyone for joining. Again, I am really going to make a concerted effort to grow this channel this year. So please do consider sharing. Do consider attending. I know some folks come for the weather and some folks come for the climate, and I would strongly encourage people who come for one or the other to stay for the other bit, either in any given conversation or from week to week. And to share the channel and the individual videos. They are, of course, always recorded and archived after the fact. You can view every live session I've ever done in perpetuity, with the exception of a couple of sessions that kind of fell apart due to connectivity issues, which fortunately did not happen today. So thanks for joining. Have a good weekend. If you are in California, enjoy the spring rain. Hopefully it doesn't disrupt anyone's plans too much. I think it's mostly a good thing, with the exception of if you're certain kinds of fruit growers probably don't appreciate these heavier April showers too much, but on the other hand, the water is beneficial. Probably schedule another session for next week. Time TBD, topic TBD, and we'll go from there. All right, everyone. Talk to you later.